So I'm attempting to do the physics test, and first of all I chose to do chapter 11, section 11.2, page 355, problem number 11. This problem talks about a rigid rod with length 1 meter, joins two particles, each one of them is 4 kilograms and the other is 3, and it wants me to find the angular momentum of the system when the speed of each particle is 5 meters per second. So first of all we have the length, which is 1 meter, and then we have the mass 1, which is 4 kilogram, and mass 2, which is 3 kilogram, and then we have the speed of each particle, which means the velocity is 5 meters per second. First of all, so the magnitude of the angular momentum of the system of the two masses would be defined as, so L equals L, which is the angular momentum, and then mass 1 plus mass 2, which is the moment of inertia, mass 1 plus mass 2, and then we're gonna have the angular speed, which is defined as Vr sine theta. So it is defined as Vr sine theta because the angle between the radius vector and the velocity vector is 90 degrees. That is because in the figure they are perpendicular to each other, and our distance between each of the mass and the origin is equal to half the length of the rod, so L over 2, and then which equals to 4 plus 3 times 5, which is the velocity, so it's m plus mass 1 plus mass 2 times v r sine theta, so 4 plus 3 times 5 times 1 over 2, and sine 90, because as we said they are perpendicular. Calculating this will give us 7 times 5 times half sine 90. If we put this in the calculator, we're gonna have 17.5 kilogram times meter squared per second. And by the right hand rule, the direction of the angular momentum is perpendicular to the plane, and that contains the radius and the velocity vector. So thus it is along the x-axis, which has a unit vector k, and so this means L equals 17.5 k kilogram times meter squared per second. So this would be the final answer for this problem due to the right hand rule. So for chapter 12, I decided to choose problem 31, page 383. This problem has part A and part B. For part A, we're gonna determine the shearing force necessary to the shear bolt, 1 centimeter in the diameter. And for part B, we're gonna define a hole in a steel plate with a thickness of 0.5. So we have the given shear. The shear stress is 4 times 10 to the power of 8 Newton per meter squared, and we have the diameter, which is 1 centimeter, and if we convert that to meters, it will be 0.01 meter. And for the thickness of the hole, we're gonna have 0.5 centimeter, and if we calculate that, we're gonna have 0.005 meters. And for part A, so we have the shear stress, which can be defined as the ratio of the shearing force to the area. So shear stress equals the force over the area, and we have to solve for force because that's what we need to calculate. And if we solve for force, we're gonna have the area times the shear stress. So we're gonna have to substitute the values. For the area, it's pi times the diameter over 2 squared. So times so the area equals pi times the diameter over 2 square, all squared, times the shear stress. And this would be force. And if we want to substitute the numerical values, we're gonna have to say force equals 4 times 10 to the power of 8 newtons per meter times squared times the pi times 0.1, which is the diameter we just calculated, over 2 all squared. If we calculate that in the calculator, we're gonna get 3.14 times 10 to the power of 4 newtons. So this is for part A. For part B, we need to find the total surface area that so for part 31B, we need to find the total surface area that the perimeter of a 1 centimeter diameter hole would have. So, which is the surface area of a cylinder. So first we're gonna have the area, which is 2 pi RT, and this would equal to 2r times pi t. 2r would give me the diameter, and pi t, so it would be d pi t. If we want to substitute the numerical values, we're gonna get 0.01, which is the diameter, times the pi, and times the t, which is the thickness, which is 0.005. Therefore, the shearing force is given by the equation as force, which equals to 4 times 10 to the power of 8 Newton per meters, times this would give me 1.57 times 10 to the negative 4, and the final force is 6.28 times 10 to the power of 4 newtons. So this is for part A, and this is for chapter 13. I decided to do section 13.1, problem number 9. So it says that there are two objects attracting each other through gravitational force, and the magnitude is 1 times 10 to the negative 8 newtons by 20 centimeter between the two objects, and it wants us to find the total mass of each of the two objects. So first of all, I'm gonna draw the two objects. So here's the object 1. I'm gonna call mass 1, and here object 2, colored red, and it's mass 2. So and here's the distance between them, which is 20 centimeter. Convert it to meters is 0.2 meters. First of all, find the total mass of the two objects. If the total mass of the two objects is 5 kilograms, what's the mass of each? So simply, if we want us to know this, we're just gonna write mass 1 plus mass 2 would give us 5 kilograms. But because we have two unknowns in this equation, so we need to generate a second equation, and the second equation turns out to be related to the gravitational force, and that acts between the two masses. And this equation would be the force times the gravitational constant times the m1, m2 over the radius. So we have the gravitational constant, which we can, like, if we want to use some algebra, so we could multiply the r squared. This would be fr squared equals g m1 m2, and then we could divide the gravitational constant. So it's fr squared over g equals m1 times m2, and it is known that the force is 1 times 10 to the negative 8, and the radius is 0.2, so it is 0.2 squared all over the gravitational constant, which is known to be 6.67 times 10 to the negative 11, which equals to m1 m2. But we can solve for m1 or m2. If I want to solve for m1, it would be m1 equals 5 minus m1. 5 minus, or if we want to solve for m2, I missed that up. So if we want to solve for m2, it would be m2, because this question m1 plus m2 equals 5. So if we want to solve for m2 equals 5 minus m1. So this would be M1. So this would be M1 times 5 minus M1. So in total this would be 5.997 equals 5 M1 minus M1 squared. So we can solve this by using either quadratic formula or factoring if this is factorable. So I decided to choose the factor method, just because if we move the M1 squared, so M1 squared plus 5.997, which could be excluded to 6, minus 5 M1 equals 0. So if I want to factor this, it would be M1 minus 2 times M1 minus 3, just because negative 2 times negative 3 is 6, and negative 2 plus negative 3 is negative 5 M1 equals 0. And then we're gonna have mass 1 equals 2 and mass 1 equals 3. So I could say through this that mass 1 would equal 2 kilogram and mass 2 would equal to 3 kilogram. So if mass 1 is 2, then mass 3 has to be if mass 1 is 2, then mass 2 has to be 3. And basically if M1 is 3, then M2 has to be 2, because if I want to plug in, so in M1 plus M2 equals 5. So if I want to plug in here 2, then 5 minus 2 is 3, and if I want to plug in here 3, then 5 minus 3 is 2. You see what I mean? And so, but because the labels M1 and M2 are completely arbitrary, the answers are equivalent. So one of them has to be like this, the opposite of each other. So if M1 is 2, then M2 is 3, and if M1 is 3, then M2 is 2. Section 14.1, first problem. The question is talking about a man sits on a 4-leg chair with his feet off the floor, and it says that the mass is 95 kilograms, and if the chair legs are circular and have a radius of 0.5 centimeters at the bottom, so they want to know the pressure that each leg exerts on the floor. First of all, so since they want to know the pressure, the definition of the pressure we have is F over A. So P is the pressure that each leg exerts on the floor, while F is the force acting on the floor, and while the area is the total area of the 4 legs. And so the force acting on the floor is the weight of the man and the chair. Yeah, the weight. So force would equal to the weight of the man and the chair, and weight would equal to the mass of the man and the chair times gravity. M is the combined mass of the man and the chair, while G is the acceleration due to gravity. And we can find the total area of the 4 legs from the formula A equals N pi R squared. N is the number of the chair legs, while R is the radius of the chair leg. And finally, if we want to substitute the F and the A into the formula, we would get P equals mg over N pi R squared, which equals to the mass, which is 95 times 9.8 over the M, which is 4, times the pi, times the radius, which is 0.005 squared. If we want to calculate this, we would get 2.96 times 10 to the 6 PA. The pressure that each leg exerts on the floor is 2.96 times 10 to the 6 PA.